In this second video, we're going to be discussing how the ideas that we discussed in the previous video, namely scarcity and opportunity cost, can be graphically illustrated with something called the production possibilities frontier or the production possibilities boundary. Okay, so PPF or PPB. These are synonyms. As usual, if you find these videos useful, please like and subscribe. And if you have any suggestions for further videos, just comment down below. All right, so let's start with a simplified version of a PPF, a linear PPF. Okay, we're going to relax this assumption of linearity later, namely because it's quite unrealistic. But it's useful to start with it to demonstrate certain sort of elementary principles. Okay, so let's just start by drawing what a linear PPF might look like. So our X and Y axis, let's say that this is some society X. And society X is a really fun place to live because people there just hang out in parks and watch sports all day. The only two things this society produces are stadiums and parks. Okay? Now the society has to decide how many resources, in our example we'll just say how many dollars, how much money, should they devote to stadiums and how much money should they devote to parks. Okay, now let's say that our budget is $1,000. Okay, now let's say it costs $10 to put up to build a park. So I'll denote that by PP, price park. Okay, so equal to $10, and PS, the cost of putting up a stadium, is $100. All right. Now, how can we represent this graphically using a straight line? Okay, so a linear graph. Well, a linear graph can be obtained by basically connecting its y-intercept to its x-intercept. Now, if none of this intercept stuff or linear stuff sounds familiar to you, I would encourage you to just maybe do a quick review of your high school level math regarding linear functions. Okay, I'm not going to be covering the details of that in this video. Rather, I'll be assuming that you're familiar with linear functions. Okay, so let's start with finding the y-intercept. Now, the y-intercept in our example simply stands for the number of stadiums, because stadiums is on the y-axis, the number of stadiums that this society could afford to produce if it spends its entire budget on stadiums, right? Namely, if it spends 0 on parks. How do you find that number? Well, super simple. You just divide the budget by the price of the stadium, right? So if you divide $1,000 by $100, you simply get 10 stadiums, right? So our y-intercept is going to be 10. And similarly, if you divide the budget by the price of a park or the cost of building a park, you would just get 100 parks, which is our x-intercept. All right, 100 parks. Now, the linear PPF can simply be represented by the line that connects these 2 points. All right, so that's our linear PPF. Now, let's find the equation of this line to begin with. So if you remember, the equation of a straight line generically in mathematics is y is equal to ax plus b, where a is the slope of the line, which is obtained by doing rise over run, delta y over delta x, right? And b here is our y-intercept. Now, of course, we already have our y-intercept, right? Our y-intercept is simply 10. So it just remains, all that remains to do is really is to calculate the slope. Okay, so the slope delta y over delta x, in our case, we'll just ignore the signs for now. Okay, we know the sign of the slope is going to be negative because it's downward sloping. All right, and of course I'll explain why it's downward sloping in a second. But for now, let's just calculate the absolute value of the slope. Okay, so we're going to be a little bit precise here and say the absolute value of the slope is delta y over delta x. Okay, so delta y would just be 10, and delta x would be 100. We would just get 1 over 10. Okay, you could also write that as 0.1. All right, so our equation for this line would be 0.1 times x plus 10, right? 0.1 being the slope, 10 being the y-intercept. So let's just go ahead and write that down. Let's make a little bit of space here. So the slope of this line is y. Okay, so I'm going instead of using y, I'm going to use our variables. Stadiums, right, is equal to 0.1 times parks. Sorry, it would be negative 0.1, right, because it's downward sloping. Negative 0.1 times parks plus the y-intercept, which is 10. Plus 10. Okay, so that's the equation of our line right there. Okay, so now let's get to why we're even. Actually, sorry, before getting there, let's talk about why this is downward sloping. It's downward sloping for a very simple reason. When you have a budget, right, spending more on one item will cause you to have less money to spend on the other item, right? So if you're spending all your money on stadiums and getting 10 stadiums, will you have more or fewer stadiums if you decide to build more parks, right? If you decide to build more parks. Of course, you'll have fewer stadiums because you'll have less money to spend on it. That's why it's downward sloping, right? Every time you gain a park, you have to give up some stadiums. All right, pretty simple. Okay, now let's talk about the point of this video, which is how the PPF or PPB actually illustrates opportunity cost and scarcity. All right, so firstly, opportunity cost. Well, I think it was implied by what I just said, right? More parks equals less stadiums. More stadiums equals fewer parks, right? More parks equals fewer stadiums, and more stadiums equals fewer parks. Right? The society has to give up one thing to get more of the other. In other words, there's an opportunity cost of investing in stadiums. And that opportunity cost is some number of parks, right? What exactly is the opportunity cost? Well, to put exact numbers on this, right? We could just write down what we could immediately see from the graph, which is that the society has a choice. 10 stadiums or 100 parks. Now, this choice is if the entire budget is spent on one good, right? If the entire budget is spent on stadiums or if the entire budget is spent on parks, this is the choice that the society faces, 10 stadiums or 100 parks. But we're interested in how much the society has to give up every time it builds a new stadium, or how much the society has to give up every time it builds a new park, right? That would be the opportunity cost. Well, in this case, we can easily find one of those two numbers. So what happens if we divide both sides by 10? So if we divide number of stadiums by 10, number of parks by 10, we get the following thing. We get one stadium 1 stadium or 10 parks. So for every additional stadium built, the society must sacrifice 10 parks. All right, so let's just move that up here. Okay. 1 stadium or 10 parks. Of course, we could also now just divide both sides by 10 to get the following statement. 1 park, 10 divided by 10 is 1, or 1/10 or 0.1 stadium. Okay, so what this is telling us is the following. The opportunity cost of building a stadium is 10 parks. The opportunity cost of building 1 park is 1/10 of a stadium or 0.1 stadium. Okay? Again, how did we get there? Well, we started with the numbers that we have, 10 or 100, and we reduced one of these numbers down to 1. First, we took this number of stadiums and we reduced it to 1 because we're not interested in the opportunity cost of 10 stadiums. We're interested in the opportunity cost of 1 stadium. So you divide 10 by 10, you get 1 stadium. You do the same thing to the other side, you get 10 parks. Okay? And then, of course, we did the same thing with the number of parks here, divided by 10. Divide 1 by 10, get 0.1. And so you get the choice of 1 park or 0.1 stadium, right? Okay, now what do we notice? Well, we notice that this 0.1 here shows up in our equation for the line, right? So this is actually maybe one of the main lessons of this linear PPF part of this video, which is that the slope of the line is equal to the opportunity cost of x in terms of y. Okay, so by x, I mean the good that's on the x-axis. In this case, it would be parks. So what do I mean by the opportunity cost of x in terms of y? Well, the opportunity cost of x, in this case, a park, is in terms of y because it's written in terms of stadiums. We're not saying that the opportunity cost of a park is some number of dollars. We're saying it's some number of stadiums, right? The opportunity cost of x is not some number of dollars, it's some number of y. So the slope of the line is the opportunity cost of building a park in terms of some number of stadiums. It's the opportunity cost of x in terms of y. All right, so that's how the linear PPF really demonstrates opportunity cost. Now, we're going to now relax the assumption of linearity a bit, but most of what you need to know about opportunity cost is, about the PPF, can really be summarized by this linear model. Okay, but now we're going to just add a little tweak to the model, and then we'll get to how PPFs also demonstrate scarcity, and that'll be it. Okay, so what does the more realistic model of a PPF look like? Well, economists tend to draw PPFs as follows. Okay, so rather than talking, so let's use the same goods as we were using before. I'll just abbreviate stadiums, parks, okay? We tend to draw PPFs like this. Oops, that's terrible. Nope. Always takes me a few tries, but I get it. All right, something like that, okay? This is referred to as a concave PPF. Now, why is it concave? Well, to see why that would be, let's divide our x-axis, our parks axis, into roughly equal slivers here. So okay. Yeah, something like that. And let's say that each of these slivers represents one additional park. Okay, so let's ask ourselves, when we go from, let's say the society is starting at 0 parks, so it's spending all of its money on stadiums. But now let's pretend that it decides to add 1 park. So it goes from 0 parks to 1 park. How many stadiums is it giving up? Well, it's giving up whatever this very small sliver is here, right? Okay. Now, let's say it decides, you know what, we can do with even more parks. So it decides to go to 2 parks. Okay. How many stadiums is it giving up then? Well, it's giving up some small number of stadiums. But that number is a little bit bigger than the previous one, right? You can see that this second arrow here, this second one, is a little bit bigger than this first one. The jump, okay, is bigger. And you could keep doing the same thing. Now, let's say it decides to go from 2 to 3. Once again, the jump is going to be even bigger. And because the PPF is getting steeper, every time an additional park is added, more and more stadiums must be given up. What's another way of putting this? Well, another way of putting this is that the opportunity cost of building a park is increasing. So you have this nice progression of bigger and bigger and bigger arrows here, which illustrates increasing opportunity cost. Okay, let's just flag that here. Oops. Increasing opportunity cost. Okay, now you might ask, well, why? Why is this more realistic than a linear PPF? You'll notice that on a linear PPF, okay, if we did the same thing, every single time we would add another park, we would essentially have to give up the exact same number of stadiums. How many stadiums exactly? Well, exactly 0.1 stadiums, okay? Now visually, of course, this is really not drawn to scale at all, but you can see that these arrows here are all the same size, okay? Over here we have constant opportunity cost, okay? Whereas over here on our concave PPF, we have increasing opportunity cost. All right, so why is this, quote, more realistic? Well, let's imagine that in this society, okay, everybody is employed either as part of a team that's building stadiums or as part of a team that's building parks. Let's call these two kinds of employees park experts and stadium experts. Well, if the society is only building stadiums, right? What are all the park experts doing? Well, the park experts are all building stadiums. Now, their expertise is in parks, but the society isn't producing any parks. They're only producing stadiums. Now, what happens once the society decides to make this leap to 1 park? Well, you're going to basically be taking away, the first people you're going to be taking away from the stadium industry are your park experts. Now, the park experts presumably were not very good at building stadiums. They were good at building parks. So therefore, the sacrifice that is made in terms of stadiums is going to be pretty low because your park experts weren't very good at building stadiums in the first place. okay? And now once you make that second leap to 2, right, maybe now you'll be taking away, maybe they'll still be park experts, but maybe they were park experts that also happen to be a little bit better at making stadiums, right? It would make sense to take the very, very best park people and the very worst stadium people first, and then go progressively lower on your park building skill list. I don't know if that really makes sense, but maybe the analogy is starting to break down a little bit. But the idea is that the park people that are really terrible at making stadiums will be the first ones to leave and move into the park industry. Okay? Now, in contrast, by the time you get to, I don't know, let's say this point along the PPF, well, now suddenly, to get to your 6th park, right? And by the way, I recognize that these numbers are different from the numbers up here. That's fine. Okay, it's let's pretend it's a slightly different society X. Okay, the numbers are not important. It's the concept that underlies the numbers that's important. Okay, so by the time we get to this decision here to go from 5 to 6, suddenly you're stealing away the very best stadium experts who are the last people really in the stadium industry, and that is going to represent just a huge loss for stadiums, okay? Now, I'm using this kind of toy example of stadium experts and park experts, but there's a general principle here, okay? And the general principle is simply that not all resources, and resources include people, not all resources are equally efficient at producing all goods. And if we decide to quote-unquote switch from, of course, there wouldn't be actual switching going on, right? In practice, the society would just pick a point and stick to it. But in our metaphor of switching from one point to the other, the first people to quote-unquote be taken away, the first resources to be taken away from stadiums will be the best park people and the worst stadium people. Okay, so the opportunity cost will be lower at the kind of earlier areas here, and the opportunity cost will be a lot higher here. So that's illustrated by this PPF, which is getting steeper and steeper as you go lower. And in fact, you can do the same thing the other way around. You'll see that I encourage you to do this for yourself to prove to you that it's true. But as the society decides to, let's do this in a different color, give up parks and build more stadiums, okay? Sorry, that's not correct. That's not what I meant to say. As the society, let's say we started at this point here, all parks, no stadiums. As the society decides to move up the y-axis in equal chunks, you will see that the opportunity cost in terms of parks is also increasing. All right. So the big difference between the concave PPF and the linear PPF is that the concave PPF, okay, has increasing opportunity costs, whereas the linear PPF has constant opportunity costs. Okay, there's a slightly different way of seeing this, okay? The different way of seeing this would be in terms of the slope of the line, okay? So let's just very, very quickly draw a fresh graph. Okay. So the slope of a curve like this is simply the slope of the tangent line at every point. Again, for those of you who might need to do so, please review your high school math on this topic. But basically, if I take a point, let's say right here, and I draw a straight line through that point that just touches the line, that's not very good, is it? That just touches the line. Okay, I don't think I'm going to draw a very good tangent line here, but imagine that line just touches this PPF at that point. The slope of that tangent line will be the slope of this curve at that point. Similarly here, the slope of this point will be the tangent line to that point. What do we notice? Well, we notice that this one is steeper. Okay, so you'll notice that the tangent lines are getting steeper as we move down the curve. That's just another way of saying that the opportunity cost of P in terms of S, right? As we said, the slope is the opportunity cost of P in terms of S, is getting bigger. Okay, once again, increasing opportunity cost, whereas, of course, on a linear PPF, the slope is just the slope, right? We have one slope, and it's constant. Okay, now, how does this graph illustrate scarcity? We've talked about opportunity cost. How does it illustrate scarcity? Well, let's take 3 hypothetical points. Call this point A, this point B, and this point C. Let's look at these. Let's look at these 3 points in turn. Let's start with A. A is what we might call an inefficient point. Okay, so inefficient. Why is it inefficient? Well, you notice that whatever combination of P and S is chosen at A, the society could have actually had more P and more S, right? If this PPF represents the budget, then at point A, the society is not spending its entire budget, right? So all it has to do is really increase the amount of spending, say to this point here, call it A prime, and just like that, it would have more P and more S, right? Over here, from S to S prime, that's an increase, and from P to P prime, that's also an increase, right? So A is inefficient for that reason. Okay, how about B? Well, B is efficient because it's right on the PPF. It's right on the budget line. The society is spending its entire budget to produce this combination of parks and stadiums B. Okay? If it wants to get more parks, so in other words, it wants to move that way, it must give up stadiums. Similarly, if it wants more stadiums, so it wants to move in that direction, it must give up parks. Okay? So in other words, there are opportunity costs. There are opportunity costs at this point in time. Now, does that mean that at point A there are no opportunity costs? No, there are still opportunity costs, of course, but the opportunity costs are just not in terms of parks or stadiums, all right? They would be in terms of, let's say, dollars, okay? That's not really the point here. The point is simply that B is an example of an efficient use of the society's budget. Now, we still haven't gotten to scarcity, but we're about to. So what about C? Is C efficient or inefficient? Well, it's neither. C is simply not feasible. Okay? It's beyond the PPF. It is simply not possible to achieve this level. Let's call this X and call this Y. It is not possible, given the society's budget, to produce X parks and Y stadiums. If the society wants to produce X parks, it must limit itself to, let's call this Y prime stadiums. And if it wants to produce Y stadiums, it must limit itself to, let's call this X prime parks. All right? So C is not feasible. Now, why isn't it feasible? Well, because of scarcity. Okay? Parks and stadiums are finite resources. Dollars are finite resources. Not every combination of those resources will be feasible because resources are scarce. All right? Now, a final point is economic growth. Okay, so I feel like I'm running out of colors here. Let's choose this one. No, not another green. Okay. Economic growth. So, in other words, economic growth is simply an increase in total output or production, okay? So if for some reason, somehow, okay, this economy becomes more productive, it becomes able to produce a higher amount of total output, that will be represented by an outward expansion of the PPF, right? So you might get a higher curve, something like that, and suddenly point C becomes feasible where it otherwise would not have been. Okay, that's economic growth. So that's going to do it for lesson 2. So far we've covered what is typically the first chapter or the first couple of chapters maybe of any typical introductory economics course. This hasn't been exhaustive, but I think it's covered the main topic. So we've talked about scarcity, opportunity cost, and PPF. If there is anything that you would like to see me do in future videos, as I said, leave a comment down below, and I will see you in the next video.